This is our first example combining actually three different transformations. If we go through this, we notice that it's in function notation. And with that function notation, when we want to sketch the graph, we've got a 4 out in front. So the first thing you can do as far as figuring things out is label what these things are going to do. That 4 is outside of the function. That's telling you it's going to affect your y, so you know that it's vertical. And we would say this is a vertical stretch because you would multiply your y value by 4. The next two things are inside your function, so I'm going to label them in a different color. The negative will make your x value negative. Now, if you think about what that means, if an x value becomes negative, it will flip over the y-axis. We will call that anything inside horizontal, a horizontal reflection. Maybe make a note that it's a reflection over your y-axis, and then your 0.5 will be a horizontal stretch. Remember that inside the function, you would do the reciprocal. 0.5 is 1/2. You're actually going to stretch and multiply your x values by a factor of 2. Now, with a horizontal reflection and a horizontal stretch, you can combine those because the horizontal reflection would multiply your x values by a -1. The horizontal stretch would multiply your x values by 2. Putting those together, you're going to multiply your x values by -2. To figure out what's going to happen to our graph as a result, we can take some key points on our original graph. So on our original graph, we notice that we have -2, 0, -1, 1, 2, 2. So if I rewrite those points below, and I use the arrows to show my transformations, I can write above this arrow that I need to multiply my y values by 4 and my x values by -2. So x values by -2, this one will become 4, this one will become 2, this one will become -4. So notice what I did there. Because I was taking 3 points, I have to multiply my y values and my x values by something. This is the key time where you can make those easy mental math mistakes because you're not thinking, because it is easy math, right? So what did I choose to do? I chose to do all my x coordinates at the same time because they were all multiplied by -2. That way I was focused on one thing at one time. And now I'm going to do my y values by 4, by 4, by 4. Because the more often you switch back and forth between something easy, the more often that you have a chance of just not paying attention to it for a second and making a small mistake. So now when I plot these points, I have 4, 0, 2, 4, and -4, 8, which would be somewhere up there, way off of my graph. And now we have, question? -2, oh, thank you, yes. Again, I was already thinking about there we go, move it up one. -2, 4. And we should label these points as well. Sometimes I find that the labeling of the points helps you realize when you might have plotted something wrong. And this one, we're just estimating that this is at -4, 8. Now, the next question that we have is we have two options. I could either start here and go down this way, or I could start here and go up this way. Don't write those down because one of them is wrong. How do we decide which one it's going to be. Well, a key point that I had on my red graph is this one. Can you see that that's sort of your starting point? That's where this square root graph actually starts. That's this point -2, 0. Where did that point end up? It ended up at 4, 0. So that 4, 0 corresponds to the -2, 0. That's going to be the starting point for my other graph. And when I now connect my points, draw an arrowhead on the end, because this graph continues on forever as well, that will be the shape of my final graph. Another thing that you can do to think about your shape is go through the things that you wrote down. Take your original graph, stretch it. Can you imagine that? If not, I'll draw it on here. Can you imagine stretching it vertically would do that? Horizontal reflection over the y-axis. Okay, that would do that. Horizontal stretch. Take it this way and stretch it out. Does it match up with my graph? So I can sort of imagine, you don't have to draw out each of the parts as you go, but sort of imagine going through the things that happened one at a time and see if the general shape matches up with what you thought it should. State the domain and range of each one. So for our original domain, it was x is bigger than or equal to -2, and our original range was y is bigger than or equal to 0. And now on our blue graph, x is less than or equal to 4. So for your domain, one of the things you're looking at is x values. I like to always think, do I have a smallest x value? So in the red function, I say yes. I have a smallest x value at -2, and it includes all the x values after that. So I wrote x is bigger than or equal to -2. For my blue graph, do I have a smallest x value? No, it goes on forever. Do I have a biggest x value? Yes, at 4. So I have everything less than 4, and I can write it like that. For the range of my blue graph, it is still bigger than or equal to 0, because now I'm thinking about my y values. Do I have a smallest y value? Yes, it's at 0, and I include everything above that. Now, one thing to look at, okay, just to analyze. If I'm just looking at my domains, do my domains match up with this? Could I multiply my range by 4? That's the only thing that affects my y values. Well, it was 0, and multiplying by 4 would keep it at 0. Those ones follow the same rules. Do my domains match up with what happened to my domains? My x values got multiplied by -2. What happens when you multiply by -2? Well, this would become a 4. And do you remember the rules with inequalities? You multiply or divide by a negative. What happens to the inequality sign? It gets flipped. Notice that that happened as well, right? We multiplied by -2, which got us the 4, and the sign got flipped. So one of the things you can do, while, even though we're finished the question, and maybe this is just the person in me that really likes math, but I analyze different parts of it. I see, how does this connect to my domain and range? How does my graph connect to these values? How do the domain and range connect to my graph? If I missed or if I didn't have a certain piece of information, could I still figure out the rest of it? And the last thing we're going to do on this question is some advanced function work. First of all, I wonder, could you write me the actual equation for the red graph? In other words, the explicit equation. Right now, so I'll write explicit equations. The red one is the easy one. The red one, which was originally labeled as y equals f of x, Do you recognize that graph? It was one of the 4 that we did right at the beginning. What did we call that one? Square root graph. Okay? So one of the things that I want you to do is not only go, I recognize that, but I want you to have the name of it. Okay? I want you to be able to say that's a square root graph, because that's going to help you remember that your parent graph for square roots has a square root sign of x. But it's not just a regular square root of x graph. What has happened to the red graph? It's your square root graph moved 2 to the left. Do you notice that these 3 points match up perfectly with the regular square root graph? So we not only have our regular square root graph memorized what its shape is, but we know those key points that go with it. And this graph has been moved 2 to the left. X to the left, I would have plus 2. In other words, we could say that the original function f of x is the square root of x plus 2. What is the equation of our blue graph? In function notation, they told us the blue graph is 4f of negative 0.5x. So if we knew the actual equation of the function, which we just figured out using our translations, could we write the actual equation of our blue graph? What do these things mean? Well, whatever's outside of the function, whatever affects your y, appears outside of the function later on. And whatever is inside of the function, which I'm going to underline in purple, that goes where the x was. Because whatever's inside the function replaces the x. Sometimes you have more than one x, then it replaces every x that appears in the equation. In our case, we only have one x, so it just replaces the one x. So our explicit equation becomes y equals, the 4 stays outside. My function is the square root of something plus 2, and where the something is, which is the x, you'd put in negative 0.5x. And this is the equation of the blue graph, the actual equation. So if you wanted to graph this into your graphing calculator, you could type this in. You can't type function notation into your graphing calculator. It doesn't help produce a graph. So we need explicit equations for that. Okay, questions for practice on this one are 7, 9, and 10.